Hello, everyone. Welcome. Just give everyone a couple of seconds to connect here. Wonderful. So welcome, everyone, and thank you for joining us today. My name is Gemma. I represent Engineers Geoscientists Manitoba, and I'll be the moderator for this session. Before we begin, I'd like to go over a few basic housekeeping items. This session is being recorded by NEM Ontario and will be posted on their public YouTube channel. Before we end this session, there will be a very short poll question for you all to answer. So please stick around so that we can get your feedback at the end. After today's presentation, Randy will do a short Q&A session. So please do send us any questions that you think of at any time during the chat function that can be found at the bottom of your screen. If you're watching on a mobile device, this may be under More or the 3 dots to the right-hand side. But feel free to put any questions that you have at any time in there, and we'll revisit them at the end for the question and answer with Randy. This session may run slightly over the 1-hour time slot that we've been allocated. There's just a lot of information that Randy has to cover, and it's super interesting. So stick with us and stay if you can for that Q&A at the end and for that feedback poll. It's now my great pleasure to welcome our presenter, Randy Herman, who will be speaking on the topic of traditional Indigenous technology. Randy is the Director of Engineering Access Program, NGAP, at the University of Manitoba. NGAP is a support program for Indigenous people who are seeking an engineering degree. Randy obtained his Bachelor of Science degree in Geological Engineering from the University of Manitoba in 1988. He worked for 10 years as a geotechnical consulting engineer and project manager in Ontario before returning here to Manitoba to take on the role as Director of NGAP. Randy, thank you so much for joining us today. It's over to you.
Thank you, Gemma. Welcome, everybody, and I'm so glad to be here today. And today I'm going to talk to you about traditional Indigenous technology, or how I like to word it is how Indigenous people change the world. So with that, I want to start here with a traditional territorial acknowledgement. I'm coming to you from the University of Manitoba, which happens to be on the Red River, which is in Winnipeg, Manitoba. And our campus here is on the original lands of the Anishinaabe, the Cree, of the OG Cree, the Dakota, and the Dene people, as well as the homeland of the group of people that I belong to, the Métis Nation. We respect the treaties that were made on these territories. We acknowledge the harms and mistakes of the past, and we dedicate ourselves to moving forward in partnership with the Indigenous communities in spirit of reconciliation and collaboration. So with that whole statement sort of is why I came up with this presentation. And I think Gemma here has already done a fairly good job of introducing me. So because I'm an engineer and I've worked as an engineer, one of my favorite shows on TV was Mythbusters. So I really like to set this up as sort of a Mythbusters presentation. And one of the biggest myths that we have out there is that Indigenous people did not have technology or science. And it's absolutely untrue. If you think about technology as being the science or knowledge that we use to solve problems or invent useful tools, well, obviously the Indigenous people who lived on this continent for tens of thousands of years did that. We talk about this idea of the science where people are studying nature and they're observing it and they're experimenting with it. Well, of course, the Indigenous people of this land were doing that as well. And you'll see as I go through that this was occurring. And of course, engineering is when we use this science and we use this technology and we use it to design and to build. We use it to design engines, machines, and structures. And although I'm not going to tell you that Indigenous people prior to colonization had engines, but they certainly had machines, simple machines, and they certainly had structures and buildings. So as I was going through the research, I realized that, there's 2 different types of sciences. There's what we would call Western science and the ideas of Western science there on the left-hand column. And then we have this idea of Indigenous science. And if you look long enough at these, you can see that they're almost opposite of each other. And because of that, when the first colonizers were coming here, there was this belief that science wasn't happening, just because it was so different than the science that they were used to seeing at that time. But it absolutely was happening. This is a well-known philosopher of science, and I find these 2 quotes to be particularly apt. And that is this idea that first world or Western science is one science among many. By claiming to be more, it ceases to be an instrument of research and turns into a political pressure group. And the other quote is that science is only one of the many instruments people invented to cope with their surroundings. It is not the only one, it's not infallible, and it has become too powerful, too pushy, and too dangerous to be left on its own. And I think if we look at some of the very complex problem the world is facing right now, we can see that engineering and science has had a role, Western engineering and science has had a role in the development of those problems and where's the solutions going to lie. And one of the reasons I put this presentation together was to get engineers to start thinking about these other ways of knowing and to bring some of these other ways of knowing into their engineering practice and into their engineering design. So originally, we all know the history that Columbus came to what he called the New World, and I'm going to try not to use that term, although it's so embedded in our verbiage that we tend to use it. And he discovered it, and of course, this world was just as old as the Old World, and it didn't need to be discovered. It was doing fine on its own. But that being said, Columbus came here in 1492, and from 1492 till the early 1600s. The Europeans tried to come up with a colony that worked here, and these are all the first 11 colonies all failed. The first number there are Spanish, then we have the French colonies, and then we have the last two are the English colonies. None of them failed, and I mean they all failed. And the reason they failed is because they didn't have the indigenous technology to work on this land, to live on this land. So really the first successful colony was Jamestown. And I don't know how much any of you know about Jamestown, but it really came into itself about 1607. And it was being completely supplied by boats that were coming over from Europe. So they weren't growing any of their own food, as being completely supplied. And some of those boats didn't make it through because of harsh conditions. Some of them were pirated. And so they wouldn't get supplies. And in those times when they didn't get supplies, they went into what they called the starving times. And now there's quite a lot of evidence that the early colonists were actually resorting to cannibalism to feed themselves. And I just want everyone to know that Jamestown is in Virginia. It's not in Nunavut, it's not in northern Manitoba, it's in Virginia. The number one industry in Virginia at $70 billion right now is the agricultural industry. So you had these colonists coming into basically Virginia, and they couldn't grow crops, which is to me astounding. And why couldn't they grow crops? Well, they couldn't because they didn't know the technology needed to grow those crops. Here's some of the innovations that I'm going to talk about today as we go through this presentation. So there's this idea that, and again, this is very much a stereotype in our modern media, is that Indigenous people prior to colonizations were completely nomadic. That very few of them were actually in houses. And again, it's very much shown in our modern day media, and this is absolutely unfounded. The best estimates is probably about 4% of all the Indigenous people in North and South America were truly nomadic. And a good example of that is what we would call the Plains culture. And this is the culture that we're used to seeing in Manitoba and across the Great Plains going westward. And that's this idea of these people on horseback and of course with teepees and traveling from one place to another. And of course, horses came with the colonizers. So prior to the horses coming, prior to colonizers, this group of people that stretched pretty much from the Mississippi River all the way to the Rocky Mountains, north to the subarctic and south down to the Gulf of Mexico, were not nomadic in any sense of the word. They were not a nomadic people. They would have maybe two homes, a winter home and a summer home, and they would move between those two homes. And some of those things that we realized that some of the technologies those people had was the teepee. We've heard of Pemmican, which is really the world's first superfood, high calorie, very, very dense food that could actually survive for a very, very long time. And jerky, which happens to be an Incan word, which is a dried meat. But here's something that was very interesting, and this is called the ring stones. And typically, the teepees you saw would be they would move the stones out from inside the teepee to the outside, and those stones would help anchor the teepee down. And in the high plateau of the Rocky Mountains, they have found these ring stones, and they have been able to date them, and they've realized that these habitations were seasonally inhabited for 4,000 years. And when they stopped being inhabited, they could trace the exact date, it was 1850, and that was the date that this group of people was put on a reservation in the States. So, think of that having that place, that history of place for 4,000 years. Obviously, these weren't a nomadic people. They would spend the summers up in the high plateau, and then they would spend their winters down in the prairies. I'm going to move a little bit further to the east and a little bit to the south. I'm going to talk about the Mississippi culture, and this is really a fascinating culture. Their head city was located just outside of St. Louis, Missouri. Today, it was called, we don't know what it was called, tell you the truth, but we call it Cuyahoga. It's named after the people that were living in that place when colonizers came. This culture had been completely destroyed or it disappeared prior to colonization. We don't know where it went. We don't know what happened to the people. There's lots of suppositions, but nothing for sure. It was a corn-based agriculture. This city had 30 to 45,000 citizens in it. It was North America's first city. In this time, around 1100 to 1200 AD, when it reached its peak, this city actually was bigger than London. But you always hear about ancient times, hear about how great London was. Well, this was a city that was bigger than London. And from archaeological restorations, we have this idea that this is what the city would have looked like. And as you can see, these people in no ways would have been nomadic. Again, they were a corn-based agriculture. They had worked goods. These are copper goods, and they were a ceramic building people. And these were some effigies that they had placed in some tombs. I'm going to move a little bit further south, and I want to talk about, this is in Mesoamerica, talk about the Aztec Empire. Some of these I know you've heard about it, and this was absolutely a civilization. There was about 5 million people. Was one of the largest cities in the world, the underneath Mexico City now, which was their head city, had about 200,000 people. And these people were highly developed agriculturalists. They built works, and if this types of works don't get built without an engineering class or a science class of people. So obviously they understood how to build these works out of stone, how to produce the stone, how to place the stone, etc. They had a written language, quite a complex written language. They domesticated the turkey. They also domesticated the Muscovy duck. And again, you can see some of their built works. And they had a breeding system for dogs, where they were breeding dogs for characters that they wished to have in the dogs. And they had a wonderful mathematical system, which was closely related to the Mayan mathematical system. And they used this primarily to determine summer solstices and astronomy as well. Moving a little bit further south to the Central America, to the south end of Central America, and we had the Maya civilization. And this was a huge civilization as well, about 2 million people and 50 to 120,000 people in any given city. And you can see that they had built works as well. Again, this doesn't take place without a scientific class. They had a written language. They had a calendrical system, a mathematical system that they used. They were writing on, they didn't have paper, but they were writing on bark and birch bark. They had a type of semi-permanent way to record things. And then the last one I'm going to look at, and again, I'm blocking together large groups of people, civilizations, if you will. Some of them may or may not have, identified themselves to be part of that civilization. They would have identified themselves to be part of a smaller one, but yet, their hierarchy, their government was the same here. And the last one I'm going to talk about is the Incan Empire. And there were many, many others. I just picked a few to talk about here. And we have the Incan Empire based in South America, on the west coast of South America. It's spread over many of the countries of South America there, as you can see. This was absolutely the biggest civilization in North and South America ever. It had 20 million people at its highest point. This is forever prior to colonization, of course. So it had 20 million people at its highest point. There was only one civilization in the world that was bigger than this one at this time, and that was the Chinese Empire. And they had built works. Many of the built works are high in the mountains, and the Incan civilization stretched across the Andes Mountains. They sort of used that area between the Andes Mountains and the Pacific Ocean. That's what they had, and because they were in the Andes Mountains, soil was very nutrient poor, so they had to do a lot of different things, and we'll talk more about that later. But they had these cities that were basically cloud cities up high. And even to this date, we're not sure how they built these cities. They're very, very high. We're not sure if anyone lived in some of these cities because they are too high to live in comfortably. They domesticated the llama. They domesticated the llama for a few reasons. One was to use its coat, but the other one, and probably more important, was to use its dung. The Incan people realized quite early the only way that they were going to be able to develop a civilization was through the use of fertilization on many of their poor soils. You know, they built these works that even today, modern day engineers and scientists are not quite sure how they built these works using the tools that they had at hand. And if you watch any sort of those alternate history shows, I can absolutely guarantee you that it's likely that ancient aliens didn't come down to build these. These were built by the Incan people. Just because we don't know how it was done doesn't mean they didn't do it. They were world-class terrace farmers, again, because they lived in the mountains. They had to develop fields that they could grow their crops on. And there's one of their cities, that's one of their cloud cities. They had a wonderful metallurgy, a wonderful metalwork that even when the first colonizers came, they weren't sure how they developed, how they produced this fine detailed metalwork. The Incans, however, didn't leave us a written language. So until very recently, it was believed that the Incans, despite having this vast civilization, hadn't developed a written language. They did leave us these though. This is called kupu. And what it is, it's knots, basically knots tied in a string. And depending on several things, the color of the string and where the knot is located, it could indicate a 1, a 10, 100, or 1,000, etc. And we realized that this was a method of accounting for them. So they had vast storehouses and they would have these kupus in these vast storehouses and they would use them for accounting what was in those storehouses. But recently it has come to light that a few elders have come in with kupu and they've actually read the kupu and they've told stories based on the kupu. It's now thought that potentially this was their written language. Again, it was so different than what the colonizers would have thought of as a written language. They dismissed it as even being possible that this was a written language. But it is quite possible that this was the language that they left us. They domesticated the guinea pig, and nowadays we use the guinea pig as a pet. The Incans did not domesticate the guinea pig to use as pets. They domesticated the guinea pig as a source of food. The Incans, because they lived in this, their empire was not very wide, but very long, it stretched a long ways, they had to build roads, and they built very, very good roads. They built about half as many roadways as the Romans, and we understand the Romans are the pinnacle of road building, while the Incans were not very far behind. And you can see, they built roads in much more dire circumstances than the Romans had to. You can see this road clutching the side of this mountain. There's an example, a map showing the roads of the Incan Empire. And here's a close-up picture showing actually the quality of the roads that they were building. You can see these are engineered roads. These are engineered structures. As I said before, the Incans lived in the mountains, and anyone who's been to the mountains know that there's sheer cliffs, and usually at the bottom of these sheer cliffs, there's a raging river. And the Incans had to come up with a way to get across these. So what did they do? They designed a suspension bridge. They were the first to use suspension bridges as far as we know in the world. 300 years before any European thought of building a suspension bridge, the Incans were using suspension bridges. We suspect there was about 200 of these throughout their empire, and some of them are still being used today. And as you can see, that they are rebuilding the suspension bridge because every couple of years it needs to be rebuilt so the villagers get together and rebuild it. These suspension bridges were able to go across longer gorges and deeper gorges than any bridge Europeans were building out of rock or mortar at the time of colonization. And here's a sort of a contemporary drawing of one of these bridges during the time of colonization. So there's this idea that Indigenous people still lived in the Stone Age, and that is absolutely wrong as well. Did they use stone tools? Absolutely. Did they understand how to work metal? Absolutely, they did. These are some of the metal working processes we know they used based on what was left in archaeological context. Prior to colonization, they knew how to do all of this stuff. What the Indigenous people in North and South America lacked was a close to the surface iron ore deposit that they could mine. If they would have had one, they would have had iron and steel, almost guaranteed, but they didn't have one, so they couldn't mine it. So they didn't have iron and steel, and that's why they had to use stone tools. Every metalworking process that was known in Europe or Asia at the time of colonization was known in North and South America by a different group of people. Here's some of the alloys that they absolutely knew how to use and how to put them together. Here's some of the works that they were able to use. This is interesting. This is a Greenland. This is a knife they found using Greenland iron. It was found in the Arctic. This knife is using iron ore. The rest are gold. This is a tin axe that came out of Argentina. And these are some steel tools, iron tools that came out of the subarctic. And so the question had been, well, where are they getting their iron from? And most of this iron happens to be meteoric iron that came to the earth in the form of a meteorite. And that brings up this next picture. This is an iron ore meteorite that they discovered in Greenland, just before the turn of the 1900s. It's absolutely huge, and it came in 4 pieces. I believe all 4 pieces weighed about 58 tons. So quite a large piece of iron. As far as we know, for many generations, we don't know how long, because we don't know when this iron actually hit. The Inuit people were using this as their iron ore, and they were trading this quite broadly. So we found it in the subarctic. We actually found an arrowhead made from this iron ore in an archaeological setting in Norway. And that was, and it was found, we know that setting was prior to colonization. So we're not quite sure how it got there, but we do know that the Inuit people were trading this ore quite far, quite widely. And the history of this iron ore meteorite, it now rests in the Museum of Natural History because Captain Robert Perry from the US Army, basically, he pretended that he found it. He basically, as far as we know, took it from the Inuit people and shipped it and sold it to the Museum of Natural History for the equivalent of about $1.23 million. As far as we know, the Inuit people did not give their okay for the iron ore, nor did they receive any money for the taking of this meteorite. And this was probably their only source of iron ore at that time. Again, this graph at the right, I show this this shows European silver production. It's the dashed line going all the way up here. And you can see after colonization, the amount of silver in Europe, that's the solid line, is coming from North and South America. So this is silver that has been mined prior to colonization likely, or just after colonization, using the mines that the indigenous people knew, and all that ore being transported back to Europe. So obviously it was, one of the greatest seizures of goods the world over. There was a small group of Ojibwe Anishinaabe who lived off the shores of Lake Superior about 7,000 years ago. This was the first group in the world to actually join the Metal Age. So this group of Anishinaabe were working copper at the same time that all of Europe, all of Asia were still in the Stone Age. They were still using stone tools. This was the first people in the world we know of to use metal-based tools. And they were mining this copper and trading it widely across North America. We found this copper in the Rocky Mountains, we found it in the Gulf of Mexico, and we found it into the subarctic. And here's where they were actually mining this copper. I don't know if you can see this Isle Royale in the middle of Lake Superior. That's where they're mining from. It's very hard to get to. The waves are very difficult. Somehow they got there, they mined the copper and they took it off. Some of the mines some of the mine tunnels are 30 feet deep, perfectly round. They go up to 1 kilometer in length. And keep in mind that the indigenous people were doing this probably with primarily stone tools. We don't know how they did it, but just because we don't know how they did it, it doesn't mean they didn't do it. So looking online, I spent about half an hour looking online, and all of these people were said to mine this copper that came from this Lake Superior, that came from these Anishinaabe people. Absolutely, the Anishinaabe people mine this copper. We absolutely know. The Chinese didn't come, prior to the birth of Christ to mine the copper here and bring it back to China. Nor did the Phoenicians. Nor did it doesn't matter who you chose. I just want everyone to know this is, this is a way of diminishing what the people actually did, right? It's a form of racism, if you will. They also had these wonderful methods of transportation prior to colonization. We know they used the travois, they used the sled, they used, again, the sled, they had snowshoes, the birch bark canoe. What a wonderful design. There's been several hundred patents on the birch bark canoe since colonization, but none of those patents has messed with the design. You look at these pictures of this design, and these were written by this book that I have was these designs were taken from in the 1930s. Actually, a Canadian engineer went to different groups who were still doing birch bark canoes, and he copied out the designs that they were using. Some of these designs are based on culture, but mostly they're based on what kind of use the canoe is being used for, what kind of water the canoe is being used in, whether it's a lake, a calm lake, or a fast moving river, or the ocean. So you can see this is engineering design, right? The same thing is true of snowshoes. Some of this design of these snowshoes is cultural, but much of the design is based on what kind of snow you're encountering, how deep that snow is, and what kind of landscape you're going across. We also have all these different methods of housing, and hopefully you can see this housing and you can think about how nomadic could these people be? How easy would it be to move many of these houses on your back? Some of them, sure, but many of them are, like I said, they're seasonal dwellings, if not full-time dwellings. As engineers, we talk about rubber and plastics and the birth of the rubber industry, and we always trace it back to Charles Goodyear. And Charles Goodyear was not the man who invented rubber. Charles Goodyear invented a way of an industrial process for vulcanizing rubber, but it was really the people of ancient Mexico and Central America who developed rubber. I believe it was the Olmec people. They were developing different grades of rubber 1600 or actually 3600 years ago. They were tinkering with the formula of rubber to make soft rubber to use in balloons. We know they were using balloons prior to colonization, as well as syringes that were made out of rubber. They were then making rubber with a harder properties in order to use it for their sandals. We have this idea of this in the New World of North and South America, of this sort of clothing technology they were using. These shoes are European. And I put them up here because this is what a well-heeled European would have been wearing at the time of colonization. And the Jesuit diaries in Canada tell us that the first thing that they did when they got here, the colonists, was they traded those shoes in for moccasins, because those moccasins are the way to get around in this place. And if you think about what modern day footwear looks like, especially athletic footwear, you'll see that it far more resembles the moccasin than it does that shoe there. They were doing leather goods. They were brain tanning leather. And what's interesting is that we know in Europe, at some point in the past, during the Stone Age, Europeans did brain tan leather. Somehow they lost that ability, and they had to relearn how to brain tan leather from the indigenous groups in North and South America. The parka was Inuit invention, this idea of taking two layers of material and having an insulating layer between it, whether that's air or some other type of material, an idea that was brought to us by the Inuit people. So prior to colonization, no one was wearing parkas outside of the Inuit. There's also this wonderful tradition in North and South America of weaving and dyeing. So much so that, every weaving technique that was known in Europe or the Middle East or Asia at the time was known and practiced in depth in North or South America. And beautiful goods they were making out of it. So I got some pictures here. As far as we know, this is the oldest cotton we have ever found. And it's not only the oldest cotton, it's also the oldest fabric we have ever found dyed indigo. It's about 6,200 years old, and was found in a cave in Peru in South America. We know that some of the first colonists, the things that they were interested in were the indigenous dyes, because the indigenous dyes, in some cases, they had colors that weren't available in Europe at the time, and in some situations, the colors they had were more vivid. So some of the earliest industries were the colonists trying to find out how the indigenous people made or created their dyes. We have this blanket that we found. This is about 2,000 years old. It's a grave good they found it. And I got this faraway picture out here. And if you look at the side, you think that's just sort of, maybe worn away and it's just maybe fabric on the sides, and it's not. I'll show you a close-up picture. It's actually this. And if anyone has ever done any weaving, think about the amount of weaving and amount of difficulty you would have in weaving something like this. It's virtually impossible using the methods they used 2,000 years ago, but yet they did it. And it is incredible. Look at how brilliant it is still for colors. And again, this good is about 2,000 years old. And here's some more pictures of it. It's just unbelievable, the quality of it. So there's this idea that Indigenous people were not agriculturalists, that somehow they were hunters and everyone was a hunter and gatherer. And that's absolutely wrong as well. This book is part of my library. I would encourage everyone to take a look at it. It talks about all the foods that came from North and South America that were developed here, that were designed here prior to colonization, and then shipped to the rest of the world. One of the major ones was the potato. The potato was an Incan crop, and not only that, prior to colonization, there was about 5,000 varieties of potatoes. So there was a vast amount of potatoes available. And this is How the Potato Changed the World is a document written by Charles C. Mann. And again, it's not that long. I don't know, 10 or 15 pages. I would encourage you to read it. Basically, the proposition is that, the potato literally changed the world. Without the potato, without a part of the potato ending up in Ireland and in Europe and creating huge population explosions, and then the disappearance of the potato due to predators of that crop, parasites, caused widespread global movement, resulting in a lot of Irish people moving, a lot of Europeans coming to the United States and to Canada, and that was all precipitated by the potato. And what really happened was the Europeans, who were basically looking at monoculture, took this potato, took a good idea. As I said, there's 5,000 varieties of potato. Many indigenous growers in the Andes Mountains still will grow 10 to 15 varieties of potato in their garden every year. The idea being that if one variety, if it's bad conditions, one variety might not go very well, but the other varieties will, so he'll always have food. Well, the Europeans, when they took the potato, they got one potato plant. So all of Europe was basically a genetic clone of that one potato plant. So when a parasite got into that one potato plant, it basically wiped out all of them. It took what was a good indigenous idea, multiple varieties of potato, and turned it into a monocultured Western idea, which eventually failed. If you look at this graph on the left, I want to point out the population explosion that happened pretty much after the colonization started of North and South America. And part of that population explosion was due to not only the crops that came out of North and South America, but also the farming methods that came out of North and South America. And I'm going to go into more detail here. There's also, there's only several places in the world that we understand domestication happened. We also understand now that it likely happened in North America. And this is a plant that's a relative of the potato plant. It's not the potato plant. And we know for a fact that it was being domesticated in the Four Corners area of the United States, in southwestern United States. Most people would know that corn is an indigenous plant from North and South America. What some people might not know, though, is that corn is absolutely a human invention. There is no such thing as wild corn. Wild corn does not grow wildly. It needs to have humans. And until very recently with DNA genotyping, we had no idea what the wild ancestor of corn was. And you know what it is? It's this. It's called teosinte, and it's a wild grain, wild grass. And how do you get from here to corn? Well, it only happens with science, right? And it happens with two scientists about 7,000 years ago in central Mexico that were actually taking corn. They were crossbreeding it with other types of teosinte to come up with corn. It doesn't happen without experimentation. It doesn't happen without an understanding of heredity. I put these headlines up here because recently, within the last couple of years, you read these, and scientists identify corn that fixes its own nitrogen. Scientists discovers nitrogen fixing corn. Scientists find possibility of nitrogen fixing corn. All of these headlines are off the internet. And what is the truth of this? Because you read this and you think there's Western scientists who are designing a new type of corn using genotyping and using DNA sequencing and all of that, and it's absolutely untrue. This corn that they discovered is actually an indigenous corn that indigenous people have been growing, likely for thousands of years in the highlands of Central America. And what this corn does, it has these roots here. I don't know if you can see them, these roots here. And here's a bigger picture of them on the right. And they're covered with this gel. And what these roots do is they take nitrogen out of the air instead of the ground, and it's available for the corn to grow. Again, this is the corn they're talking about. It's indigenous people have been growing this corn for thousands of years. And not only is it working and it grows in very, very poor nutrient soil, it's also about twice the size of regular corn. And it can grow without the addition of fertilizer. So if this ever takes place, it's probably going to save the world between $17 billion to $17 billion in cost savings, not only all the problem of the environmental harm of nitrogen. We shouldn't be congratulating the scientists who discovered this corn, because they did not discover it. And in addition, the local farmers who have been growing this corn have been asking scientists from the 70s, since the 70s, to come and look at their corn. And it wasn't until 2010 or 15 that someone actually did. What we should be asking is, who should profit from this nitrogen fixing corn? Because I can almost guarantee you, it is not going to be the indigenous people based on history. Squash, we understand squash to be the oldest domesticated plant in the world. We've found 12,000-year-old squash seeds in an Ecuadorian cave. Again, all squash varieties, they come from North and South America. All these types of beans, kidney beans, common beans, tepary beans, lima beans, are all North and South American crops. Not only that, we have evidence that they were deliberately hybridized between 2 or 3 different wild ancestors to come up with a crop that grew in the climate they wanted it to grow in, tasted the way they wanted to taste it, et cetera, et cetera, et cetera. So we absolutely know that they understood agriculture. Here's more foods that came from the Americas. We have peanuts. This is chocolate, by the way. So you always hear about Swiss chocolate and Belgian chocolate, not prior to colonization. Every pepper came from North and South America. All those cuisines nowadays that you think about that depend on the pepper, I don't know what they depended on before colonization, but it wasn't the pepper. Maple syrup, very interesting. Maple trees actually grow around the world. Europeans had to come to basically North America to learn how to tap a maple tree to get the maple syrup out of it. Tomatoes, and every time I see this slide, I think about all the wonderful tomatoes that I ate when I went to Italy, and the tomato pastas and the tomato paste and everything else. Absolutely, they didn't have that prior to colonization. Tomatoes were invented by the Aztec people. We have this, and again, the one thing I would talk about in terms of the words that we use and how that we use these words in order to demean, whether consciously or unconsciously, a separate culture. We call this wild rice, okay? It isn't wild. Indigenous people have been using this domesticated grain for thousands of years. It's not only not wild, it's not even a rice, it's a grain. Why do we call it wild rice? Well, we call it that so we can pretend that the people that originally lived here were not farmers, that they were hunters and gatherers. Sunflowers, they grew across North America. Not only were they using the sunflowers to eat, they were crushing the sunflowers into flour. They were using sunflower oil for all the same reasons we use sunflower oil today, plus a few extra. They were using it as a medicine as well. And here's even more foods that come from the Americas. All of these foods come from the Americas. I'm not going to read them all out. Cassava, maybe many of us have never heard of cassava because we don't eat it in North America. Cassava is a tuber. That's a picture of it on the right. It actually grows in more nutrient-poor soils with even less water than a potato will grow in. So this is the food that's basically feeding many of the developing countries in the world today. All these nuts come from the Americas, and none of these were wild at the time of colonization. All of these nuts have been domesticated. And when you talk about that cashews, the domestication process and the process for making the cashew not poisonous is quite intense, and indigenous people knew how to do it, which leads us to believe that they had some understanding of chemistry and what constituted certain things. The original potato that they grew could not be eaten without quite a lot of preparation, which included chemically neutralizing it. So if you look at the top 10 food crops in the world, you can see that 4 of them come from North and South America. And when I put this slide up, I like to talk to people about thinking about the huge biotechnology companies today that are changing the genome of corn, let's say, and then they're selling that corn every year and disallowing farmers to regrow that corn, so that you've got to keep buying the corn from those farmers every day, from those giant companies every day. And I just want people to think about corn is a human invention. If the indigenous people at the time of colonization would have had a good patent lawyer, nobody in the world would be growing corn without paying some surcharge to the indigenous people of North and South America. And when you look at how much corn is grown, it wouldn't take much of a surcharge to make them the absolutely richest people in the world. Not only were they growing corn, they had a method of farming which was completely different than the monoculture that was coming out of Europe at the time. They did what was called companion planting. That's the technical term for it, I guess. We call it the 3 sisters. We grew corn, squash, and beans, and in some communities it was 7 sisters. But in general, we grew corn, squash, and beans in one small plot of land. It's messy. It doesn't look like a farm. So the colonizers, when they came, they could look at this and say, well, that's not really farming, because it didn't look like their farming, but it absolutely was farming. And why did we go grow corn, squash, and beans together? Well, there's a very good reason, a very chemically based reason that we did that. Because what beans do, they take nitrogen out of the air and they fix it into the soil through their roots. Well, corn needs a huge amount of nitrogen to grow. And if, modern day farmers, if they grow corn on their fields once, maybe twice in over 2 years, the 3rd year they have to put a heavy amount of fertilizer on that farm in order to continue to grow corn. When you grow it as a companion planting, then the beans give the nitrogen to the corn, right? So you don't have to fertilize it. So what is the corn? The corn gives the beans a scaffolding to grow around. So why squash? Well, squash, not so much for a chemical reason, but squash has a broad leafy canopy. So that protects the corn from drying out. Not only that, raccoons, which is one of the main predators of corn, doesn't like to go through the squash because of the stickiness and because of the little prickles in it. The squash also repels certain insect predators. So they use the squash basically as a pesticide. Indigenous people could literally put this in the ground, take care of it for a couple of weeks, go for 2 or 3 or 4 or 5 weeks hunting or fishing or whatever they want to do, come back, watch it for a couple of weeks, leave again, come back and harvest. This was completely different than what European farmers had to do. So because they saw this happening, they decided to say that the people that they saw in North and South America weren't farmers, they were hunters and gatherers. Absolutely not true. Not only that, corn, squash, and beans can provide you exactly a healthy balance of carbohydrates, proteins, healthy fat, and vitamins. It's almost an ideal diet. If you added meat to it once in a while, you're good to go. So entire civilizations in North and South America depended on this crop and this growing method. We talked about those Incan people, and they lived in the mountains, and they lived in mountainous lands, wasn't terribly good soil. So what did they do? Well, they understood they had to have fertilizer, and their llamas and their alpacas, there wasn't enough fertilizer coming. So you had this chain of islands off the coast of South America, this chain of islands. And for ages on these chains of islands, these migratory birds have been nesting and depositing guano there, so much so that it's in quite thicknesses. Well, the indigenous people, the Incans, would take their boats out and they would harvest this guano, they'd bring it back to the mainland, and they would use it to fertilize their soil. One of the first instances of industrial scale harvesting of fertilizer. It wasn't really well understood by the Europeans at that time. When they saw what was happening, the first thing they did was they started harvesting those islands. And they took the guano from those islands and they brought most of it back to Europe. And you can look at, we don't hear much about it now, but wars were fought over this guano, and they called them the guano wars. Who owned this guano and who was able to take this guano back to the North and South, back to Europe and Asia. So one of the reasons, as I showed you before, that Europe was able to feed its growing population was because of the taking of this guano. Not only that, we know from records that the Incan people actually had a moratorium against hunting these birds. It was actually punishable by death to hunt these birds. So we understand now that it was one of the first instances of environmental policy among ancient peoples that we have ever found. The other thing is now that the guano from these islands is completely gone, and many of these birds are endangered species. We talked about Jamestown, and this is a representation of Squanto. And Squanto was an indigenous person who lived near Jamestown. And according to the records of the Jamestown people, he was a close friend of theirs, and he was the one who actually taught them how to live and how to grow crops in North America. And what he's doing here is he's putting a fish, which would not have been a fish that you could eat. It'd be an oily fish, or in some instance, they would just use a fish head. He's putting a fish in the ground, and in that fish, either in the mouth of it or underneath the fish, he puts a piece of corn. And as the fish rots, it provides fertilizer to the corn. It was a trick that, again, those early settlers to North America didn't know, and he taught them. When we hear about the Amazon jungle, we're thinking about this vast area that's, basically a pristine rainforest, the pristine forest that no one's ever touched. And as we clear cut more and more of the rainforest, more of the jungle, we realize that that's absolutely not true. We realize that there was a civilization of people in the Amazon jungle. They were manipulating, they were engineering their soils. And we have this soil called terra preta, which is Portuguese for black earth. And you can see it up here against the typical Brazilian soil. And these plants are the same age. So you can see how much better the terra preta soil is. It is an engineered soil. We know for a fact it's got fish bones in it. It has charcoal in it. It has broken up ceramics in it. We don't know what else they put in it. This soil, by and large, is still fertile. We have fields that are over 2,000 years old, and the soil is still fertile. It kind of beats even what we're doing today in terms of composting and getting compost in soils. You can see the thickness of it. It looks to be between 3 and 5 feet thick here. On the right, you have a map here. All these black areas are where they found in the Amazon jungle, where they found this terra preta soils. Some of these are fields that range from 50 acres to 900 acres in size. And I just want you to think about a 900-acre field, 5 feet deep, the amount of engineering effort that it would have taken to create such a field, right? There absolutely was a civilization here. At the time of colonization, that civilization disappeared, likely due to disease that ran ahead of the colonizers, but we're not 100% sure. Also, we know that it was gone by the time the first colonizers got here. We have this idea, this is up in the Incan highlands. We originally thought it was just a terraced farm. And you can see these are actual people, so you can get an idea of its scale. Recent tests have identified that there's a 19-degree temperature difference from top to bottom. And now we're starting to realize that this was probably one of their laboratories. This is maybe where they're coming up with the 5,000 varieties of potato, because, if you're going to live in a mountainous region, a potato that's going to grow at 1,000 feet is not going to be a potato that grows at 3,000 feet, right? You have to take into account the difference in height, the difference in rain, and we believe that this is maybe where they were designing those different crops. They had what we know to be the world's first hydraulic pump. They were digging these channels in the ground here, and they would dig the channel till they intercepted an aquifer. And what this channel does, it allows the wind to pressurize the water. So it basically becomes a hydraulic pump. So somewhere down the line, you can turn on a tap and you can get pumped water. This was created about 2,000, 3,000 years ago. It's still being used today. It's in Peru. And it's possible that people in Peru who did the Nazca lines were the same group of people that designed this. Now with this modern day scanning technique, we're able to scan through what looks like virgin rainforest, which was what this is in Belize. It looked like virgin rainforest. And now we see that all of these are actually irrigation channels. This is not natural. This is irrigation channels. We believe that this might be where some of the crops were being grown to support the Mayan Empire. We now understand that indigenous farming practices, especially in the Amazon basin, we're using what we call managed landscapes. They absolutely were keeping trees and taking down trees and growing things. And I have this, you can see these huge geoglyphs that are coming to light now. Again, civilizations did this, not nomadic people. And I just have this quote The Amazon rainforest was profoundly changed by ancient humans. The region's ecology is a product of 8,000 years of indigenous agriculture. This is based on a scientific paper in Science, the persistent effects of pre-Columbian plant domestication on Amazonian forest composition. They were doing the same thing in North America. They absolutely were. It wasn't a wild, untamed landscape as some of the original colonists would tell you. It was absolutely a farmed landscape. And we had an early settler who came across, an early explorer. His name was Giovanni Verrazzano. In 1524, he sailed up the East Coast, and this is what he had to say, right? This was not almost an impenetrable primeval forest, but a landscape mosaic comprised of a biophysical environment greatly altered by the Aboriginal peoples. So they were doing that. They had farms, they had gardens, they were taking care of everything. This is on the West Coast. It was also happening, and this is from a couple of archaeologists talking about the indigenous people of the West Coast. They were active managers who promoted and valued plant resources, and thus have much more in common with farmers than previously supposed. We have this idea of aquaculture. This came from a modern day, I got it about a month ago, off a Department of Fisheries and Oceans website, talking about aquaculture being known to the 1800s in Canada. And yet, we know for a fact there's clam beds in BC that are over 3,500 years old. We have the Manjikaning fish weirs just outside of Toronto, by Orillia, Ontario, probably the oldest constructed works on Turtle Island in North America to trap fish. All these types of farming, by the way, were all invented by indigenous people, mainly on the West Coast. Of fishing, I meant. Indigenous people did not practice modern medicine. Absolutely wrong as well. If you think of this sort of definition of modern medicine, which medical doctors and other healthcare professionals treat symptoms and diseases using drug, radiation, or surgery. Indigenous people use drugs, then they use surgery. The thing they didn't use was radiation, so they had 2 out of 3. Here's some of the drugs. Basically, it's been found that we have not synthesized a drug from a North American plant or animal that wasn't already being used by an indigenous group prior to colonization to treat the exact same symptoms we use that drug to treat today. Not a single drug. Every drug we had was already being used. Here's a list of just a few of the plants that we know they were using in North America. Even today it's happening. This is a headline from December 2019. A couple of researchers got $850,000 to look at a cure, a birch bark extract for eczema. In the 60s, we know that the traditional people on the West Coast were often used the Pacific yew tree to treat symptoms of cancer. And from that, we synthesized Taxol oil, which happens to be a drug that we use for cancer. At the time of colonization, this is what Western medicine might have looked like. They were up on bloodletting. They would use pole cyst, blistering. You know, many of the people who would have traditionally used herbs prior to colonization, many of those people were likely wiped out during, like they were probably treated as witches, and that whole idea of using herbs in wild medicine to treat people was on the wane in Europe at the time of colonization, and doctors hadn't really moved back to that idea yet. We know for a fact that they used all of these methods for treating wounds and for treating people. They invented the forceps. We know they were the first to make and use syringes. They used sutures. They did brain surgery. They were the first people in the world to use anesthetics. They used oral contraceptives. At the time, just shortly after colonization, Prince Philip II of Spain, he sent his court physician to Central America, to Mexico, to work with the Aztec healers, because the Aztec healers were known as being the foremost in the world at that time. And he spent 7 years there, and he came up with this book, which was brought back to Europe, brought back to Spain, and was republished many times, was translated to many different languages. And I can only believe that in some way this had some effect on what we see as modern medicine today. I think I'm going to end there. I think that's, indigenous dentistry, again, was also highly ahead of the Europeans at the time. They were making and using dental inserts, and you can see this person has actual a tooth. I believe it's made out of stone, carved out of stone, but in addition has dental implants. You can see these implants here. These implants weren't for a dental purpose. They were completely cosmetic, but the fact is they were drilled in there and likely drilled, and the tooth shape was changed. And presumably this didn't cause abject pain to the person who had this done. They would use spruce gum. The reason they would pick off wild spruce gum and they would chew it. They taught the early colonists how to do this. They chewed spruce gum for two reasons. It's an antiseptic, so it kills germs in your mouth. But more importantly, spruce gum also will clean your teeth. The indigenous people knew the absolute importance of cleaning their teeth. They used toothpicks. They had a rudimentary toothpaste, and they used toothbrushes with that toothpaste to clean their teeth. And I believe that's the end. And I have a number of slides. Thank you to our partners and our sponsors here. And after this, I have a number of slides of references. I'm not going to go through them. I'll turn it over to questions, but I think you'll have access to this presentation in some form. So if you want to see some of my slides, you can do that. Gemma, I am done.
Thank you so much, Randy. That's such a fascinating presentation. You fit a lot of information into the last 53 minutes. So thank you so much. So everyone that's listening, now it's time for question and answer session with Randy. So if you have any questions at all, please do go ahead and pop them into the chat box that you can see. You can find your chat box at the bottom of your screen. As I said before, if you're watching on a mobile device, something with a smaller screen, you may find it under more or under the 3 dots in the corner of your screen, depending on what you're watching. We've had a few comments coming in from some teachers that are working right now, Randy, actually teaching on a similar topic, and they're finding that your information is super helpful. They're really looking forward to watching this again and hopefully sharing it with their students as well. And I was just wondering, you did reference that you had some other references that you wanted to highlight. Is there anything in particular that you'd like to share with those teachers that are watching? Any kind of things that they might want to share with their students, whether it's websites, whether it's particularly interesting books that you know of that you'd like to highlight for them?
You know, this is a portion of them, and I think most of them are available, still available, probably online. Some of them are out of print, I know, but any one of these books is very, very interesting, and just the amount of material. You know, I guess my journey started probably with this book here, 1491, very, very introductory text, and I found it very good, and then I worked from there. Guns, Germs, and Steel is also very good, and I'm pretty sure it's probably still in print or just recently out of print. Good book. You know, again, some of this stuff like this science article, just came across this recently. It's online. So any one of these are really good sort of starting text. You know, if I had teachers out there, what I'd like to say is that every one of my slides could be a standalone treatment for a lesson plan at a school level. And just to, get some of those keywords and to access some of the, great resources we have now online through that slide could easily be done.
Perfect. So we do have some questions coming in, Randy. I'll start with a question from Pat. They say that was an awful lot of information. They really enjoyed it. They were wondering if modern takes on Indigenous technology by Indigenous people are flourishing, and if you have any examples of that. If modern takes on Indigenous technology by Indigenous peoples are flourishing.
I would say that they're not flourishing, but my suspicion is that they will start to flourish given the complexity of some of the problems that we have nowadays. And some of them are definitely flourishing in the sense that, just want to get back to one picture. Some of them are definitely flourishing in the sense that we are still using them today, but they've been sort of usurped or absorbed into Western culture, and we just call them Western. Like, for instance, like I said, the canoe, that's flourishing. Everyone goes in a canoe, right? And that design of that canoe is actually, that's a design from the traditional people of North and South America. If you look at medieval shows of Europe, they're not using what looks like a canoe. They're using a dugout, and very often those dugouts are very, very poorly dug out in terms of how they look. They look like just someone took a basically very little idea put towards the design. So that's an example. And there's so many others. Look at all the food we're eating today, right? All that food all that food we're eating today is flourishing. Tomatoes, peanuts, sunflowers, right? These are great crops in the world. So all that is flourishing as well. One thing I like to wrap my mind around is sort of this thought experiment, is that the last 500 years or 600 years, we've grown based on a monoculture crop, and all our technology is based on this monoculture crops that we have. What happens if right at the start we'd have thought, oh, companion planting is the way to do it, and all of our technology would have grown to harvest companion planting crops? What kind of difference would we have in the world today, right? Because the companion planting is, by its very nature, less intrusive on the environment. And some of these things, I think, are going to start to come around.
And kind of leading off your comment about the companion planting is a question from Jennifer. So the question is, for the Three Sisters planting, I think if I tried that today, I would have powdery mildew on the corns and beans. Do you know of pesticide control methods that were used, or was planting done to allow for good air circulation?
Well, that's a good question. I know a couple of things, first of all, and one of the things is that even the corn, the beans, and the squash we would use today are probably very, very different forms of the corn and squash and beans that traditional people would have used 500 years ago. So that could be a part of the problem, is that the corn we're growing is different than the maize they would have grown, like I said, 1,000 years ago, 500 years ago. So that could be part of the problem. I probably would have had a more hardy corn that would have resisted that sort of growth on there. I have heard, and I don't have the resource or the reference for it, but I do know that there is a group or a company of Indigenous people, and I believe they're either in North Dakota or Minnesota, who have developed a traditional farming seed reservoir, let's call it, or library, whatever you want to call it. I don't know if they will give you seeds. I don't know how it works. I don't know how much it costs. But if you wanted to really try it, you could get in contact with them and find out the actual corn, squash, and beans they would have used.
Wonderful. We have a very technical question from Francisco.
Yeah, and I saw it
Did you see?
19 degrees.
Yes. So
I'm
yeah, for
looking
people
for it in my notes and I can't find it. I must not have transferred the notes over when I transferred the slide over.
That's okay. Francisco, you know what? We will find out that answer for you, and we will contact you after this presentation. So sometimes we don't know everything, but we will find it out for you and we will get back to you. A question from Jana, who is one of the teachers actually that's watching today, about how would you envision teaching this kind of material to engineering students? And Randy is a professor at the university as well, aren't you, Randy? So that's a pretty good question to ask.
I think it would all depend on, making it, because engineers are they're very tied into making it relevant to the course you're teaching. So I think it would all depend on the course you were teaching and trying to make it relevant in that way. If you're talking about a fourth year or, electrical circuits course, I don't know how you would make it relevant. I don't have the background to know that. But in certain courses, certainly it can be relevant to engineering students, not just the technology, but also some of the cultural pieces. And one thing I'm adamant about here at the university, and I'm trying to get people to think about this, is that I believe that no single engineering student, but especially no single civil engineering or biosystem engineering student, should graduate from any university in Canada without having a cultural water teaching from the traditional Indigenous group that is closest to that university. Almost everyone had a water teaching about the sacredness of water. And one of the things that we understand in Western culture is that water is a commodity, and it's to be bought and sold. And Indigenous people would no more have thought of buying and selling water than they would have thought of buying and selling air. It just wouldn't have been something they would have thought of. But to have that traditional teaching to inform our young engineers on the importance of water to our economy and to our, not just that, but of clean water to our economy and to our sustainability of life on this planet. So that's one way that I would incorporate it, not so much, and I'm not talking about the cultural side, but I think it almost has to be on a case-by-case scenario. And for the 80 slides I have here, I left out 80, 90 slides. I did this presentation to a group of students in UBC Okanagan. And what I wanted to do, I thought, well, make it a little bit local. So I'll add a few local examples. Well, when I started to research the people of the plateau and in the interior and the coast of BC, I completely redid this presentation, and I added, again, I took out 60 slides and I put in 60 slides that was just based on the technology of that area. So everything I'm trying to get at is, in your area, I am sure there are ways that you can incorporate the Indigenous knowledge of your area into your engineering classroom. Again, I did so much broad strokes that I actually didn't get down into the details of the design. That wasn't my goal. So if it is your goal, you can look and find what the Indigenous people were doing and bringing that in. A good example is the teepee, and how they actually constructed a teepee. Was for its thermodynamics. Now, I'm not a mechanical engineer. I'm not going to talk to you about the thermodynamics of a teepee, but they are definitely there. And you could easily bring that into a thermodynamics class and talk about how the teepee is a thermodynamic entity and how it actually works, and how Indigenous people were actually constantly thinking about heat flow inside of a teepee. But again, I'm not the guy to do that because I'm not a mechanical engineer.
It's a great answer though, Randy, thank you. Okay, so we have one last question before we wrap up today. And just a reminder to everyone, please do stay tuned for a couple more minutes. This is a great last question, then I do have a quick poll for you. So our last question comes from Frankie. Hi, Frankie. And Jason and Timmy are also watching as well. Frankie is age 9, Randy, so he may be our youngest viewer today, I'm not sure. And his question is, when do you think Indigenous people will get credit for their science? It's a good one to end on, hey?
Yeah. And I know little Frankie. Frankie, sometimes he dresses up as a hero of mine, Gabrielle Dumont. So little Frankie is a son of a friend of mine. So great question, Frankie. You know what? Through this presentation, I'm hoping, and I've done this presentation probably 15 times in the last 10 months. So I'm hoping to give him that credit. So hopefully it's coming. I think it's coming slowly, but then every time I see one step forward, I see 2 steps back. So what I mean by that is, one step forward, I see some acknowledgement going, and then I come across a headline that talks about scientists discover nitrogen fixing corn. And I'm realizing, yeah, I'm going 2 steps back now. So it's a slow process. And I think all we can do as people is to make sure that we give that credit to the Indigenous people in the territories that we live in, give that credit of that they lived in this territory. They lived in these very harsh climates for 10, 20, maybe 30,000 years, potentially prior to Europeans coming over. And they didn't do that luckily. They didn't do that by coincidence. They did that by having engineering and by having a science and by watching the natural world. And we have to give them the respect for that.
Perfect. Well, once again, Randy, thank you so much. Just before everyone leaves, I am just launching a poll that you're going to be able to see on your screen now. And thank you so much. We still have 45 people here with us today, which is wonderful. Thank you for sticking with us for the extended question and answer period. We didn't want to cut Randy short. He's just such a wealth of knowledge on this information. So quick poll question that's showing up on your screen just from NEM Ontario, who are putting on these presentations throughout National Engineering Month this March. They just want to know what you think. Did you learn new or deepen existing knowledge, skills, or values? Was this event helpful to you, your community, or your organization? And would you be willing and likely to attend another NEM Ontario event? So if you can click those buttons just so that they can get some feedback on that. I'll be leaving that up for just another 5 seconds.
I'm so glad that there was teachers in here.
Yes. Yeah.
And that's so awesome.
Yeah, we've had a real variety of people attending today and a lot of great feedback coming through. Okay, yeah. Closing the poll in 3, 2, 1. Okay, everybody. So I just want to say on behalf of NEM Ontario, Engineers Geoscience Manitoba, presenter Randy Herman, and myself, I'd like to thank you all once again for attending today, for your excellent questions and your wonderful feedback. Thank you so much and have a wonderful rest of your day and happy National Engineering Month, everybody. Bye.